Hello everyone, welcome to Testport MBA Prep. So we are starting with inequalities. This is part 1 of inequalities. We have two parts. And previously we have covered the linear equations, quadratic equations. So if you haven't watched those parts, you are advised to watch those videos. And again you can come back to this lecture. So before starting that, if you haven't subscribed our channel, do subscribe it, and you can also join our Telegram group. I have shared the joining link in the description box. So inequalities start with trichotomy property. So this is a basic property. Almost everyone knows this. So what is this? If we consider any two real numbers, let's say A and B, right? So exactly what can happen is either A will be less than B, or A can be equal to B, or else A will be greater than B. Other than this, it is not possible. There is no other condition other than these three. So in the second case, in which A is equal to B, we will deal all this in equalities, right? In equations. Whereas the first condition, which is A is less than B, and the third condition, which is A is greater than B, these are inequalities, right? So we will deal with inequalities with these kind of conditions. So what is the addition property of inequality? Let us say A and B are real numbers and A is less than B. Then if I add one more number, right? If I add, which is also a real number, let's say I am adding C to A, right? And again I am adding C to B also. Then what will happen? Will A plus C be less than B plus C, or it will be greater than B plus C? It will be less than B plus C, because we are adding the same value on the both sides, right? So same goes with A is greater than B as well. So A plus C will be greater than B plus C. Then what about the subtraction property? So if A is less than B, then if we subtract C from A, right? And then we also subtract B from we also subtract C from B, then this will be again less than B minus C, right? So if A is greater than B and we are subtracting C from A, then this will be greater than B minus C. These all are basic properties just to observe what is happening, right? Just for observation, I am just repeating them. And what about the addition, adding and subtracting inequalities? Let us say A is less than B, right? These are real numbers and A is less than B and C is also less than D, okay? Then how can we combine these two and express in a different form? We can do like this. We can make this these two as A plus C is less than B plus D, because the greater values, if we combine two greater values, these will always be greater than the two lesser values, right? So A plus C will always be lesser than B plus D. So this is the adding and subtracting inequality property, and the properties of multiplication and division. So if we say A is less than B, right? And if we multiply A with C, and also if we multiply B with C, if C is positive, then A into C, AC is less than BC. This condition remains same. Until C is positive, this condition won't get affected. This sign won't get affected. What happens if C is negative? So A into minus C, now B becomes B into minus C. So when we are multiplying A and B with negative signs and with same number, then this inequality swaps over. That means AC will be greater than BC. Here AC is less than BC, this inequality remained same because C is positive. Here the inequality swapped over because the sign got changed. Sign is negative, right? So this is one more observation that we all have to make. So in this part we will look into six important properties. We will apply these six properties in six different problems. So the first property is, if the sum of variables is constant, then their product is maximum when the numbers are either equal or as close as possible. Either equal or as close as possible. Let us take an example so that you will understand this property better. So let us solve this. If a plus b is equal to 36 and a and b are natural numbers, then find the maximum possible value of a into b. Right. So here the sum of variables is given, right? Sum is given, and we are asked to find the product, maximum possible value of this a into b. So we shall apply this. Here what is the condition? The product is maximum when the numbers are either equal or as close as possible. So if we just observe a plus b is equal to 36, these two must be either equal or as close as possible. So we can simply say 18 plus 18 is equal to 36, right? So these are equal, right? In case these are not equal, these must be as close as possible in order to make the product maximum. But how can we apply this? If the numbers are somewhat complicated, then what can be our approach? We shall look into this now. Let me erase this first. So a plus b is equal to 36, right? If we consider 35 plus 1, this is equal to 36. If we consider 33 plus 3, this will be equal to 36, and so on. 30 plus 6, this will be equal to 36. So 20 plus 16, this will be equal to 36. However, 18 plus 18 is also equal to 36, and 17 plus 19, this is also equal to 36. And if we multiply these two individuals, right, 35 into 1, 33 into 3, right, if we multiply these two, the product will be maximum for 18 into 18. That is what this property is all about, right? So the product is maximum when the numbers are either equal, or in case they are not equal, they must be as close as possible. So in this case they are equal. So 18 into 18, which is equal to 324. So this is the maximum possible value of a plus b is equal to 36, right? As close as possible condition also. Here initially we had 36. So if this were 17, right, a plus b is equal to 17, then find the maximum possible value of a into b. So in this case, a plus b is equal to 17, right? A plus b is equal to 17. So 17 is not a perfect square, right? But we can say that 8 plus 9, this will be equal to 17, right? 8 plus 9 is equal to 17. So perfect square is not possible. So these two are as close as possible. So in this case, 8 into 9, this will be equal to 72. This is the maximum value possible, right? So if we move on to the second property, if the product of variables is constant, then their sum is minimum when the numbers are either equal or as close as possible. So in the first case, the sum is constant. In the second case, in the second property, product is constant. So product is constant and sum is minimum, right? So the condition is same. Numbers must be either equal or as close as possible. Okay. So let us take this. If a into b is equal to 324 and a and b are natural numbers, perfect. Then find the minimum possible value of a plus b. So what is the condition given? A into b is equal to 324. and we are asked to find out a plus b minimum possible value. And what is the condition? The numbers must be either equal or as close as possible. So if you are very well aware of the square roots, you can say 18 into 18, that is equal to 324, and you can directly say 18 plus 18 will be equal to 36, and this is the minimum possible number. But how can we do that in a step by step manner is, see, 1 into 324, this is 324, but what is the sum? 1 plus 324, this is equal to 325. And in the second case we will take 2 into 162, right? This is 324 and the sum is 164, right? So we want the minimum possible value. Okay, so in the third, so if we move on like this, right, at last we will get 18 into 18, this will also be equal to 324. However, the sum is 18 plus 18, this is 36, this is the minimum possible value. No other value is lesser than 36, hence 36 is the minimum possible value for a plus b. And now we shall take the as close as possible case. Here the numbers are equal, 18 and 18, but we will take the as close as possible case. So if 324 was not given and if we were given 132, right, if we were given 132, then 132 is not a perfect square. So however, 132 is almost 11.5 whole square, right? So it lies between 11 and 12. So these are the values which are as close as possible. So 11 plus 12 is the minimum possible value for a plus b in this case, right, in 132 case. So 11 plus 2, this is equal to 23. 23 is the minimum possible value for a plus b in this case. So let's move on to the third property, which is if a plus b is equal to constant, some constant, then the maximum value of a power m into b power n is equal to a by m is equal to b by n, right? So when a by m is equal to b by n, we will get the maximum value of a power m into b power n, and a and b must be real numbers, right? So we shall apply this in this question. So find the maximum volume of a cylinder if the sum of its radius and height is equal to 12. So what is the volume of a cylinder? Volume is pi r square, right? Pi r square h. So pi r square h is the volume of cylinder, and the radius and height is equal to 12. So radius plus height is equal to 12. So what are we asked? We are asked to find out the maximum volume. So maximum volume is pi r square h maximum, right? And if you observe, we cannot maximize the value of pi. This is constant. We cannot maximize this. The only thing that we can maximize is r square h, right? So we can make it like this, r square h, this can be maximized. But what is the condition here? A power m into b power n, this will be maximum when a by m is equal to b by n. So a by the power is equal to b by the power, right? So here it is in the same way. So r square h, a power m by b power n, h power 1. So r by 2 is equal to h by 1. So the ratio r and h is equal to 2:1. So r plus h is 12 and the ratio of r and h is 2:1. So r should be equal to 8 and h must be equal to 4. Right? R is equal to 8 and h is equal to 4. And if we substitute this pi into, so r square 8 square and 8 8 square 64, 64 into 4, this will be equal to 256. So 256 pi is the maximum volume which is possible for this cylinder. So this is how we apply this apply our third property. Let us move on to the fourth property, which is if a power m is into b power n is a constant, then the minimum value of a plus b is when a power a by m, that is a by the power of a, when this is equal to b by the power of b. So when this is possible, then we will get the minimum value of a power a plus b, right? When a by m is equal to b by n, we will get the minimum possible value of a plus b. We can apply this as we applied to the previous properties, but first let us look into the other properties as well, and then we will apply these properties one by one. So this property is almost an extension to the previous property. So when a constant is added to a and one more constant is added to b, what happens is we can get the maximum value of a power m into b power n when k1a by m is the power of a, is equal to k2b by the power of b. So when this is possible, we will get the maximum value of a power m into b power n. Now we shall apply this in this question. So if 2x plus 3y is equal to 15, then find the maximum value of x square into y cube. So 2x plus 3y is equal to 15. So this is in the form k1a and 3y is in the form k2b. This is equal to some constant, right? And we are asked to find out x square y cube, the maximum value of x square into y cube. So if we observe this property, the maximum value of x square y cube, in this case a power m into b power n, is possible when k1a by m is equal to k2b by n. So when k1a by m is equal to k2b by n. So in this case, what is k1a? K1a is 2x by what is m? M is 2. This is equal to k2b. 3y by n is 3. So 2 and 2, 3 and 3 get cancelled. So x is equal to y. So as x is equal to y, we can replace the value of y and x. We can interchange respectively. So 2x plus 3, in the place of y we are substituting x. 3x is equal to 15 and x is equal to 3, and in the same way we can find the value of y. So y will be equal to, this will also be equal to 3. So as we want to find the maximum value of x square and y cube, just simply substitute these two values. So x square, 3 square, so 3 square into y cube, 3 cube, so 3 square into 3 cube, which is equal to 3 power 5, and this is equal to 243. So 243 is the maximum value of x square into y cube. So we are simply using these properties, we're simply applying these properties, nothing else, right? So this is one more question related to the fifth property, which is if 2x plus 3y plus 4z is equal to 27, then find the maximum value of x power 4 into y square into z cube. Okay, and we know the fifth property, which is k1a by m is equal to k2b by n. So in this case, 2x by this power 4, right? 2x by 4 must be equal to 3y by the power of y. So 3y by 2, this will be equal to 4z. 4z by the power of z, which is 3, right? So if you remember, we discussed one concept in ratio proportion, which is the sum of the numerators by the sum of the denominators. So what did we learn in ratio proportion? So we learned that if a by b is equal to c by d is equal to e by f is equal to g by h and so on. So this will be equal to the sum of all the numerators a plus c plus e plus z by the sum of all the denominators, which is b by d plus f plus h, b plus d plus f plus h, and so on, right? Okay, so the sum of numerator by sum of denominator. We shall apply the same in this problem also, in this concept. So the sum of numerator, what is the sum of numerator? 2x plus 3y plus 4z by, what is the sum of denominator? 4 plus 2 plus 3. So this will be equal to, so denominator is equal to 4, 2 and 3. This is 9. And 2x plus 3y plus 4z, we know this is equal to 27. So 27 by 9, this is equal to 3, right? So if 2x plus 4 is equal to 3, right? 2x plus 4 is equal to 3, then x is equal to 6, and if 3y by 2 is equal to 3, then y is equal to 2, and if 4z by 3 is equal to 3, then z is equal to 9 by 4. But we are asked to find out the maximum value of x power 4 into y square into z cube. So this maximum is equal to, just substitute the values of x, y and z. 6 power 4 into 2 square into 9 by 4 whole cube, right? If we simplify this, we will get 3 power 10 as the maximum possible value of x power 4, y square and z cube when this is equal to 27. Let's move on to the last property of this session. So the last property says if a power m into b power n is equal to some constant, right? So then k1 into a plus k2 into b will be minimum when k1a by m is equal to k2b by n. So k1a by the power of a is equal to k2b by the power of b. So in this case it will be minimum. So we shall apply in this question now. So if xy square is equal to 27, then what is the minimum possible value of 32x plus y? We want the minimum possible value of 32x plus y. But what did we learn? We learned that the minimum value is possible when k1a by m is equal to k2b by n, right? So when k1a, what is k1a? 32x. So 32x by the value of the the power of x is 1. 32x by 1 is equal to y by the power of y, which is 2. So x is equal to y by 64. Xy square is equal to 27. So x is equal to y by 64. So if we substitute the value of x here, then y by 64 into y square, this is equal to 27, and y will be equal to 12. If y is equal to 12, we want 32x plus y to be minimum, right? Minimum. So y is equal to 12. So y is equal to 12 and 32x. How can we calculate 32x? Value of 32x. Just substitute the value here, value of y here. Then 12 by 2 is equal to 6. So 32x is equal to 6. So 6 plus 12, this is equal to 18. So 18 is the minimum possible value of 32x plus y. So these are the 6 properties, important properties. Remember them, revise them, and when you apply, it will be more clear for you, right? More clearer for you. And in the next video, next part, we will learn the remaining all properties, right? All the concepts, we will apply them, and then we'll move on to modulus concept. So thank you very much. Thank you for watching this. If you haven't subscribed our channel, do subscribe it, and also you can join our Telegram group. All the very best, and thank you.